Physics Part 83. Now it's your turn. Some weights are hung from a light rod AB as shown in the figure. The rod is pivoted. Calculate the magnitude of the force F required to balance the rod horizontally. Center of gravity. An object may be made to balance at a particular point. When it is balanced at this point, the object does not turn, and so all the weight on one side of the pivot is balanced by the weight on the other side. Supporting the object at the pivot means that the only force which has to be applied at the pivot is one, to stop the object falling, that is a force equal to the weight of the object. Although all parts of the object have weight, the whole weight of the object appears to act at this balance point. The point is called center of gravity, which is CG of the object. The center of the gravity of an object is the point at which the whole weight of the object may be considered to act. The weight of a body can be shown as a force acting vertically downwards at the center of gravity. For a uniform body such as a ruler, the center of gravity is at geometrical center. Equilibrium. The principle of moments gives the condition necessary for a body to be in rotational equilibrium. However, the body could still have a resultant force acting on it which would cause to accelerate linearly. Thus, for complete equilibrium, there cannot be any resultant force in any direction. For a body to be in an equilibrium, the sum of the forces in any direction must be zero. The sum of the moments of the forces about any point must be zero. We got the summary for this section. The moments of force is measure of turning effect of the force. The moment of a force is the product of the force and the perpendicular distance of the line of action of the force from the pivot. A couple consists of two equal forces acting in opposite directions, whose lines of actions do not coincide. The torque of a couple is a measure of turning the effect of the couple. The torque of a couple is the product of one of the forces and the perpendicular distance between the lines of action of the forces. The principle of the moments states that the sum of the clockwise moments about a point is equal to the sum of the anti-clockwise moments about the point. The center of gravity of a body is the point at which the whole weight of the body may be considered to act. For a body to be in an equilibrium, number one, the sum of forces in any direction must be zero. Number two, the sum of the moments of the forces about any point must be zero. We've got some section questions. Number one, a uniform rod has a weight of 14 Newton. It is pivoted at an end and held in a horizontal position by a thread tied to its other end as shown in the figure. The thread makes an angle of 50 degrees with the horizontal. Calculate A, the moment of the weight of the rod about the pivot. B, the tension of T in the thread required to hold the rod horizontally.